Yes. Is the screen visible to you? Is my screen visible to you?
No, ma'am. Yes,
Okay. Let me
it's
see.
not visible.
It's not visible. Let me try to share it again.
No, ma'am.
Okay, okay. I'm trying to connect it, but somehow it's not coming up. Okay. I hope it's visible now.
Yeah, it's visible, ma'am.
Sure. So, sorry for that delay. So, my question was outer CSH forms before the formation of inner CSH. Yeah. So, I saw that many of you have answered it as true. So, I would like to know some of you, if you can put it in the chat box, through what method does the formation of outer CSH takes place and through which method the inner CSH forms? So, this was covered, I think, in week 2, the formation of outer and inner CSH. So the correct answer is anyway true. That is, outer CSH forms before inner CSH. But what is the method through which the outer CSH forms? Can someone comment? Yes. So Rauser has commented that it is through solution method. What about inner? Yes. Shrish, the outer is through solution method, not topochemical. So inner is in situ or topochemical. Yes. So I hope that is okay for everyone. So we move to the next question. So I'll just put it in the chat box as well for those who cannot see the screen. The darker phase in backscattered electron imaging is A. Unhydrated cement grain, B. CSH, C. Pore, and D. CH. I'm asking about the darker phase or the black phase. Yes. Okay.
Option B, ma'am. CSH.
Option B, CSH. Okay. Option A is unhydrated cement grain. Okay, I'm getting three different answers. So, how does the backscattered electron imaging works? So, the electron from the scanning electron microscope comes with a high velocity. It hits the material or the sample, whichever we have kept, and it scatters back, right back. And whatever scanner we have kept, it will capture those electrons. So, if you have a very dense phase, the whatever electrons get scattered, it will be more. That means the more number of electrons will get scattered if the phase is denser, which will make the image more brighter. So if we have a denser phase, then more electrons get scattered, and that will cause a brighter phase. So if you think otherwise, if you have a very less dense phase, then only very less amount of electrons will be backscattered, which implies that the image will be very dark or very less bright. So here the question is the darker phase. So which means that the phase has to be of less density. Among the four options, it is very clear that pore will be having a very less density compared to the other three options, that is unhydrated cement grain or CSH or CH. So the correct answer is pore. Okay. So in the case of backscattered electron imaging, what darker phase form is the pore. Okay. So we move to the next question. Choose the correct option with respect to density. So here we have four options. Option A is CSH having a higher density than CH. Option B, C3S has a higher density than CSH. Option C is Portlandite having an equal density as that of CSH. Also, the last point is C3S has an equivalent density as that of CSH. I am waiting.
Option A, madam.
That is, CSH is having higher density than CH. Right? Who was it? Sheikh Usman. Are you the one who answered?
Option A, madam. CH
CSH greater having greater density than CH.
greater than CH.
Okay. Do you have any justification for that? Why do you say option A? Okay. I guess we are not having any justification. Anyway, I got different options as correct answer here A, B, and D. So I would like to remind that CSH structure is not a well defined crystalline structure. It is a layered structure with water or pores inside, pores filled with water inside. So which makes density much lesser. So from all these options, what makes sensible is C3S having a higher density than CSH. CSH will definitely not have a higher density than Portlandite because Portlandite has a crystal structure, CSH is having a layered structure. So the correct answer is B, C3S having a higher density than CSH. So thank you all for those whoever answered. Thank you. And those who thought it is anything other than option B, stay corrected because CSH is having a layered structure and with water inside, so it is having a lesser density. Okay, so we move to the next question.
Also, when we can bring out that in the microstructure, what Sir has explained, that the denser particles will be brighter in color, like white. So C3S will be, the unhydrated particles will be white in color, and the
Yes.
CHS, what Sir was trying to bring out, will be grayish sort of thing all around the
Yes.
unhydrated particles.
Yes. If you just clearly note from the lecture what Rao sir told is correct. That is, whatever having a higher density will be shown in a brighter or whiter phase. So if you see C3S will be much whiter in that case than CSH. CSH will be in a grayish tinge of color. So adding on to that, yeah. So now we move to the next question. CH or Portlandite, it has a higher tendency to form away from the aggregates. State true or false. CH is Portlandite or calcium hydroxide. It has a tendency to form away from the aggregates. So it's a true or false question. Please feel free to express your opinion. It can be either right or wrong, no issues. Okay. So I'm getting a mixed response here. Okay. So basically, Portlandite will be forming near to the aggregates because it has to have space for the formation, first of all, because the paste which is very near to the aggregate is much porous, has IT set. So that paste will be much porous. In that scenario, more of the Portlandite will be formed close to the aggregate and not far from the aggregate. So CH always has the tendency to form near to the aggregates and not away from the aggregates. So the correct answer is false. I hope that is correct. I mean, that is okay for you. It has the tendency to form near to the aggregates and not away from the aggregates. We move to the next question. So here is something which you have to read carefully and answer. So the question is choose the correct statement or statements. It can be either one or more than one. So the first statement is inner CSH governs the concrete durability. Okay. Now the second statement is porosity is higher for inner CSH than outer CSH. Third one is outer CSH has more inclusions for or of sulfur and alumina. Option D, monosulfates intermix with inner CSH. Option E, as the fineness of the cement increases, dissolution rate decreases. I hope the statements are pretty clear. It's more about inner CSH, outer CSH, durability, etc. So I'll give some more time for you guys to read. Make sure that you read it correctly. Choose the correct statement or statements. So it can be one statement or more than one statement. Okay. So I'm getting more answers of A and E. A and C. Okay. Does any one of you have any justification for? Okay. Anthony, sir, do you have any justification why you opted for A and B? Or anyone else like Prashanta?
A cannot be correct because outer CSS is more porous. So for durability, the outer CSS should be less. So inner CSS will not govern the durability, right?
Okay. Yeah. Thank you, Shrish, for commenting.
And
Yeah.
for B porous, outer CSS is more porosity.
So you're clearly ruling out A and B.
Yes, ma'am.
Okay. What about C?
C, inclusion of sulfur and alumina is more for inner CSH than outer CSH.
Okay. What about
And
D?
D, I am not able to recall, but as the for E is correct as the fineness of cement increases, the dissolution also increases.
So E is also
Post
wrong.
no E, so D maybe will be correct.
Okay. So here I want to comment that fineness increasing means the particles are becoming more and more smaller.
Yes, ma'am.
Yeah. So when the fineness increases, it is surface area increases,
Yes, ma'am.
particle size decreases. So as the particle size decreases and the surface area increases, it is always better for reactivity. So reaction, how it
And the
happens?
hydration will be higher.
So
And the specific surface area is more, the rate of hydration will be more.
yes. So E has to be wrong. What do you say? As he rightly told, as the specific surface area is higher, reactivity is higher. How do we tell reactivity as? Reaction happens when the particles dissolve and then reprecipitate, or dissolve and crystallize, or dissolve and form new compounds. So when the particle size keeps on decreasing or the surface area increases, dissolution must be more. Right. Am I making sense here? So the last statement is that as the fineness of the cement increases, dissolution rate should increase.
Yes, ma'am.
Yeah. So E is wrong. E has to be wrong.
Yes.
I agree with Shrish for A and B. A is wrong because inner CSH does not govern the concrete durability. It is the outer CSH which governs the concrete durability. Please stay corrected. Why? Because option B is the answer. Porosity is higher for inner CSH than outer CSH is a wrong statement. Porosity is higher for outer CSH than inner CSH. So that is why outer CSH governs the concrete durability. Now, Moving on to the correct answer, it is just C. Outer CSH has more inclusions of sulfur and alumina because it is more in contact with the surrounding paste. It's not the inner CSH which is in contact, it is the outer CSH which is in contact. Yeah. Any comments? Okay, I hope that is clear. So the correct answer is just C. Okay, so all the others are wrong statements. Okay, we move to the next question now. Arrange in the increasing order of gypsum solubility. So gypsum or calcium sulfate, it's available in different forms as hemihydrate or dihydrate or anhydrate. I can rephrase this question as arrange the increasing order of calcium sulfate solubility. Okay, I'll give some more time for you guys to think and answer. I'm seeing A and B are correct answers for in the chat box. I'm waiting for more of your participation. There are 47 attendees, at least 46 attendees. So please feel free to express your opinion. There's nothing wrong if it goes wrong. So solubility is a very important factor because unless it is soluble and if the dissolution is more, then it can take part in the hydration reactions, then it can take part in the system. If not soluble, it is just inert as any other inert material. So we have to carefully choose what kind of calcium sulfate, what form of calcium sulfate we are adding. So I guess that's it. No more answers are going to come. So I got A and B, both are as correct answers. So it's not A, definitely, because in option A states that all the hydrates or dihydrate or anhydrate or hemihydrate forms have the same solubility, which is not true. The correct answer is B, that is dihydrate having the least solubility and the synthetic anhydrate has the higher solubility and hemihydrate has the takes the middle ground. So anhydrate higher than hemihydrate, higher than dihydrate, which is option B. So I'm glad that most of the attendees have answered it correctly. So having said that, we move to the next question. The technique through which we can determine the cations in pore solution. So professor was speaking about pore solution extraction, how difficult it is, and what are the different methods through which we can get the pore solution, etc. So how can we chemically determine? Okay, okay, there I'm getting sem as a correct answer. Okay, I am again saying it is a pore solution and it's a cations. Okay, I'm just curious why sem. Can someone comment? Vignesh, are you there? Okay, you are commenting B. Okay, Sony, are you there? Why sem? How sem? Can someone who commented C justify why C? I'm just curious, and if it might be the correct answer, so I'm not choosing you like that. It might be someone who commented C. Come on, please feel free to unmute and speak, or else if you can put it in the chat box as well. Okay, so I guess no more answers are coming up. I got C, B, and A are correct answers as correct answers. So Moving on, X-ray diffraction is a technique through which we can understand the crystalline peaks, or if you have crystalline materials in the sample, it gives a characteristic peak. From that, we can get to know the composition. Again, X-ray fluorescence, we get the oxide composition. Then scanning electron microscopy, it is a microscopical technique through which we can understand the different phases present. So it must be CSH, must be CH, it must be ettringite. In none of these cases, we can particularly pick the cation, or cation meaning sodium positive or potassium, K plus or Na plus or Ca2 plus. So in none of the cases of B, C, and D, we can get to know the cations present in the pore solution. That only method through which we can get to know the cations is through atomic absorption spectroscopy. We can give a pore solution, keep the solution, we can pass the rays, and then there will be selective absorption, and so through that we can get to know what type of cation was present in the solution. So the technique, you'll learn it in detail either in this course or through using during the characterization of construction materials course. You'll learn this techniques in detail. So the particular technique through which we can determine or characterize the cations in pore solution is atomic absorption spectroscopy, which is option A. Okay, I hope that is clear. Or why B, C, and D are not the correct answers. At least that I think you guys are okay with. Moving on to the next question. This is fairly an easy one. Choose the correct statement regarding the pore size. Capillary pores are having a size greater than gel pores. Gel pores are having a size greater than capillary pores. Then both are of equal size. So there was a question in the discussion forum, what are capillary pores? So those are the pores which are present in the cement paste but which is outside the CSH. It is not within the CSH, it is outside the CSH. They are capillary pores. Gel pores, on the other hand, it is present within the CSH gel. That's why it says gel pores.
Ma'am, with respect to this capillary pore and gel pore, ma'am,
Yeah.
when professor was telling us, when we take out this concrete sample and put it under the SEM,
Mm.
we are not able to see the capillary pores because it's a two-dimensional element. What we do the scanning,
Ah.
something related to that, because it's just a small, what we say, from top we are able to
Ah,
see that
got
it's
it. I think that he was telling about pore and void, right?
yes, ma'am, pore and void, ma'am.
Yeah.
So in that, ma'am, when the specimen, if it is placed in a such a way, can't we see the depth of that pore,
No,
ma'am? Because
no, that is the problem. No. So in scanning electron microscopy, especially if it is a backscattered electron imaging, the specimen preparation itself is we make a flat surface. We make a polished surface. How much ever polished it is, the better. So in that case, we are looking through the microscope or the camera is facing the top surface. Suppose I am looking a flat surface. I'm just seeing a hole. I clearly don't know how deep the hole is.
ma'am, now what you're telling is we are looking from top like this.
Yes. Yeah, I
If the
can see
same
you.
element is cut like this and
Oh, I was not
it is
seeing
cut,
you. Sorry. Yeah.
ma'am. Whenever we talk about SEM like this only, ma'am,
Yes,
and
yes,
we are seeing from top.
yes.
But the same element, if it is cut like this, ma'am,
Yes,
then we can see
definitely
the
you can see the depth. Yes.
depth like this, ma'am. So if
Yes.
the same the specimen what we prepare,
Mm.
instead of cutting on top layer by layer, if we
Mm.
cut it in a lengthwise, ma'am,
Lengthwise.
then
Okay.
can we see the entire that, because it will be continuous structure pore, ma'am, which capillary
Sir,
pore
then
which is
I'll
present
ask you
here.
another question. See, that's just something which came to my mind. You are assuming that, see, what can I take from here? Okay. You're assuming
Not
that,
simple, ma'am. This way.
yeah,
You also took
exactly.
the mobile, ma'am. I also took the mobile.
Yeah,
So we are seeing this like this,
yeah,
rather than if we see like this. Now this line which is there, ma'am, can't
exactly.
we
Got
see
it.
this in
Got
the
it.
SEM?
Got it. You can see that. But how do we know that the pore in the sample, that is small sample which you are taking, is like this, how can you ensure that? What if there is
While
a
cutting, ma'am, while cutting, if we mark on the concrete sample itself, what is the top and what is in any way, ma'am, the pore has to be either this way or depth wise, anything. The pore will be through and through if it has to be
yes,
formed in a concrete
yes,
sample.
yes.
So that we can see actually in SCM, ma'am. That's what I was thinking. Why
Like
can't we make out?
we see in this case also, if the pore, we are cutting it like this we are cutting, if the pore is like this along the horizontal plane, then we can see it, then we can
Yes,
see
ma'am.
the depth.
Yes, ma'am.
Okay, suppose as you said you're cutting it like this, if
Ma'am.
the pore is like this, then you can see the depth again. But
Ma'am.
what if the pore is like this?
Then we can't see,
We
ma'am.
can't see. So yeah, so we don't know in a particular concrete specimen what type of pores will be in
How
all
the pore is
direction.
running around.
Yes, how was a pore oriented or aligned, we never know. So that's why we tell that backscattered imaging, we cannot determine the size of the pore.
Okay.
I hope that's clear. Okay, so coming on to our question. Yeah. So the correct answer is capillary pores are having a size greater than gel pores. Gel pores are very minute, so it is present within the CSH gel. Again, one more question related to capillary pore, gel pore itself. Choose the correct statement regarding the pore volume as proposed by Powers. So I here by take a what do you call, like I don't want to clearly mention that capillary pores are of greater volume or gel pores are of greater volume, like that I'm not mentioning. I'm getting this question with a pinch of salt, that is, as proposed by Powers, according to him, what is the correct statement? Capillary pores are greater than gel pores, or gel pores are greater than capillary pores, or both are present in an equal amount in the material.
Now it is one third of the pore space is composed of gel pores, ma'am. This is what Power said.
Yeah. So of all the sorry, what?
Ma'am, as per Powers, ma'am, he
Yeah.
said that one third of the pore space is composed of gel pores and the rest are capillary pores.
Yes. So clearly, Powers told that the capillary pores are of the greater occupy the greater pore volume than gel pores. Am I correct? Am I making some sense here? Rightly, Power told that out of all the pores, one third is gel pores, two-third is capillary pores. So, gel pores are of lesser volume than capillary pores. But again, I told you, I'm taking this as a pinch of salt. According to Powers, according to his calculations in the initial uh, period of concrete technology, this was the case. But there are certain research papers or results, even in our video itself, sir was projecting. In one case, capillary pores seem to be of higher volume than that of, sorry, gel pores seem to be of higher volume than that of capillary pores. So, like that, also there could happen. So, that's why when I included the question, I just told according to Power's proposition, capillary pores are of greater volume than gel pores. Okay, so we move to the next question. This is a true or false question. I guess chat box answering itself is better than putting it in poll. Okay. Capillary pressure and the associated shrinkage strain are higher when water is removed from larger pores than from smaller pores. State true or false. So I am proposing, or my statement is that uh, is my screen still visible to you?
Yes, ma'am.
Okay. So I guess there was multiple screen sharing happened. Okay. Anyway, I hope if it is clear, well and good. So my statement is that when you remove water from a large pore, it causes more shrinkage or capillary pressure than
Screen not visible, ma'am.
it's not visible. Okay, let me try. There was one Gokul, can you unshare?
Visible right now. Advanced computer technology.
Yeah, I think one more person shared the screen. That's the reason. I think it was Gokul. Can you? Okay. Okay, let me see.
Madam, screen not visible, madam.
Yeah, yeah, I'm trying to resume it. Please don't try to share your screen while the live session goes on.
Okay, done, madam.
Yeah, okay. I know it might have happened without even your notice, so that's fine. So the question is this one. So I'm getting so many answers. Let me go through them. Okay. Most of them have commented it's false, and Naveen has commented it's true. It's okay. So whatever system it be, if you're trying to remove water from small pores, it will cause a it will require a higher pressure than it is very easy to take something out from a larger bowl. If it is very small bowl, you have to take all the pressure you have to remove what is from inside a small bowl. So similar to that, if you have a larger pore and if you have a smaller pore, to remove water from a smaller pore, it is very difficult. So the capillary pressure and the associated shrinkage caused when you remove water from a smaller pore is much higher than what is happening when you try to remove from a larger pore. So my statement is false. It will take higher pressure and it will cause higher shrinkage strain if you remove water from a smaller pore. Okay, so I hope that is clear for you. Move to the next question. This is a very easy one. Hydration of cement causes increase in volume, decrease in volume, does not change in volume. Does not cause a change in volume. So this is a pretty basic question. Hydration of cement. So you have all the raw materials with you. You mix everything and the cement hydrates. So now the hydration, it causes a decrease in volume or increase in volume, or it does not change volume. Okay, let me make the point clear. Volume as in the solid volume. The volume of the solids. Okay. So I'm getting again mixed answers here, A, B, and C. So I thought this was a fairly easy question. Okay. So even if you have seen the calculations done by professor, he considers that there is a volume reduction happening. That volume reduction of 25.4% is associated because of the formation of pores within the structure. So the correct answer is decrease in volume and not increase in volume. Okay. So cement hydration, it causes a decrease in volume, not increase in volume.
Ma'am,
Yeah.
associate this question as per shrinkage that is happening in after the hydration?
No, 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 no. See, shrinkage does happen even if there is, we assume that there is no shrinkage, or even if we take the first second after after we pour water, immediately the hydration happens. So even if you take like that, where shrinkage we assume as zero, there is a reduction in the volume.
Okay, this condition is called the instant after the
Yes.
water is.
Yes. I mean, generally, what you told is correct. Shrinkage also causes decrease in volume. Even if there is no shrinkage, generally we tell no A plus B gives C plus D. Here A plus B is having a definite volume. C plus D is having a lesser volume than A plus B. The remaining volume is pores in the system. I hope that's clear. Yeah. So we go to the next question. Characteristic porosity of CSH gel. This was calculated through multiple trial errors, experimentations, and simulations. So CSH gel has a characteristic porosity of 25 percentage, 23 percentage, 28 percentage, or 25.4 percentage? Yeah, I would encourage you all to please answer. That will keep at least the chat box interactive. Okay. Option B, option C, option D. I know option B is a bit confusing, right? Because for 1 gram of cement, it was 0.23 gram of water, which is required for fully coating the cement, full hydration of 1 gram of cement. So from there, you might remember option B. Unfortunately, it's not option B. So 25.4 percentage, you remember from the reduction. That is the porosity, 25.4. Correct answer is C, which is 28 percentage. That the characteristic porosity of CSH gel is C, which is 28 percentage. Okay. So we move to the next question, which is again a true or false question. Here, ettringite are present as needles, whereas monosulfates are present as plate-like structures. Whether it is a true statement or a false statement, generally speaking. Okay. Okay, so I guess it's clear for you all. It's correct answer is true. Okay, we move to the. That was a fairly direct question. I guess I don't have to explain. The tringates are generally forming as small needles. Monosulfates are plate-like structures. Yeah. Move to the next question. The Feldman-Sereda model is associated with which hydration product? The Feldman-Sereda model is associated with the ettringite, monosulfate, CH, or CSH. I'm waiting for more answers in the chat box because among 46, 6 or 7 answers is not what I expect. At least half of the class can answer. This is a fairly easy question. We dealt with only one model, I guess. Yeah, only one model in the along this course of this lecture. That was Feldman Sereda model. That is associated okay, it also tells that the structure is layered structure with different water inclusions in it. Yeah, so as most of you rightly told, yes, the correct answer is CSH. So the Feldman Sereda model is associated with the structure of CSH. Okay, so we move to the next question. The CSH gel structure changes depending on the hydration temperature. So carefully read the question. So I'm talking about the CSH gel structure. It changes depending on the hydration temperature. Okay, it's just true or false. I got one true and all the other false. Okay, four falses. Okay. The correct answer is true. That was also covered by Professor Manu in the lectures because when you change the hydration temperature, you get to see that the CSH gel forming is having layers, but again, the surface area keeps on changing. Sometimes it has a very high surface area, keeping that layer uh, itself, it has a different surface area. So generally the CSS gel structure itself, it changes depending on the hydration temperature. So the correct answer is true. So moving on to the next one, the hydration product which can lead to volumetric expansion in concrete. So here I'd like to explain the question. So if something is formed in concrete, it causes expansion. Options are CSH, CH, ettringite, monosulfate. So what causes an expansion? So I don't know whether you might have heard someone who have learned concrete technology before might have learned about delayed something formation. So that is another issue. So that is the answer for this question. So if that particular product is forming at a delayed time or at a later stage, it will cause expansion. And if the concrete is already set by that time, it will not be able to withstand that expansion, all those things. Yeah. So here Anthony sir has commented, yeah, delayed ettringite formation. So the correct answer here is ettringite or option C. So this conversion of monosulfate to ettringite, all these, it causes an expansion. So whenever the ettringite is formed, so it comes along with an volumetric expansion. So that is why even in shrinkage compensating cements, that what they actually do is that they'll make the cement such that it expands initially itself, so that once when it shrinks, it will come to the original shape or the required shape and size which we want. So shrinkage and expansion both are contradicting phenomena. So what if there is already an expansion in the initial stages? Once it shrinks, it will come back to the original state. So that is how the shrinkage compensating concrete works. So in that case, also what they go for is a formation of ettringite. So the next question is: air entrained concrete finds its use in high density concrete, freeze thaw, and corrosion inhibition. Air entrained concrete finds its use in high density concrete, freeze thaw, and corrosion inhibition. So why do we generally knowingly input air in concrete? Why do we do that? Someone, can you please unmute?
For better ventilation.
Yeah, and also,
And the water has to expand, ma'am. In freeze-thaw conditions, the water has to
yeah,
have some space for expansion.
mm,
So
yes,
if these air voids are there, then basically to avoid any cracks in the cracks to
yeah.
get
The
in.
water which goes inside the concrete, it can find some space if the air voids are present to expand. So basically, if there is no space available, it will try to expand and cause the crack. When it freezes, anyway, it expands. So in order to avoid that, in the case of freeze thaw conditions, we generally knowingly, deliberately, we introduce air in the concrete. So we can't just. So the correct answer is again option B, which is freeze thaw. Okay. Why do we do that? Because in freeze thaw condition, there is a volumetric expansion which happens when the water freezes, and there should be some space available within the concrete for the water to freeze. If not, it will try to freeze, and then it will cause cracks on the concrete. So it's a durability issue. So in order to avoid that, we introduce air. But we cannot just simply put how much ever air we want. So the distance between the air bubbles in the air entrained concrete should not be more than. Okay, you can always ask how to ensure this, or how to be more sure that this is how it is happening and all. But theoretically, the distance between the air bubbles and the air entrained concrete should not be more than. So, what is the maximum limit, maximum distance between two air bubbles? You cannot simply introduce air again and again. Okay. So, I'm getting different answers: A, B, A, okay, C, okay. I changed that unit just to confuse you.
No, it's
So,
200 microns.
yeah. So, the correct answer is A, 200 micrometer. Okay. So with that, we came to the end of the live session for the week 3. It was nice
Ma'am,
discussing
one
with.
small doubt, ma'am.
Yeah.
In the previous session, when one of the participant had asked one doubt, ma'am, regarding this compressive strength of mortar and this thing, ma'am, I could actually understand that. We generally test the compressive strength of a cube, that is concrete.
Hmm.
But what was the discussion about that
Ha.
mortar and cement test, ma'am? Because compressive strength is always related to the 150 cube, what we do the concrete test, ma'am, on the cube.
Needn't always be on site, yes, but here when in the research facilities, we generally go for concrete mortar, sorry, cement mortar cubes. So what you are asking is from the live session with the professor, right?
Yes, ma'am.
So
Actually, I could understand because whenever we have done, like in our colleges, we have done on the cubes, concrete cubes.
nowadays we do it on mortar also. We
So the
generally
same specimen, ma'am, the specimens are created of the same size, or
needn't
we
be,
can
we
actually
have
use
It will be 70.6 mm for mortar cube.
mortar cubes. Even we can go for, if it is a lime cube, or we can go for 50 by 50 as well. We just need to give a proper loading rate,
Ma'am,
etc.
is there any
And
IS
these
code
players
provision on
will,
this, ma'am?
Sorry.
for
Any
players
code?
will,
Okay, Anthony sir, can you speak?
for players we are using 50 mm.
Okay, yeah, thank you. So Rao sir,
Ma'am, any codal provision, ma'am, on this where we can see the what is the specimen sizes, and because IS code provides about this regarding the concrete cubes.
okay, okay. For
Similarly for
mortar,
cement mortar.
for lime mortar, I can say because I work on lime. Sorry. So for that, IS 2250 is there.
Okay, ma'am.
IS 2250 for lime. That is for masonry mortars. I think it is there for cement also. Cement mortar is also coming under that category only. If it is a masonry mortar, then that is the case. We can
Okay,
go
ma'am.
for. So
Such
the question was why we go for mortar, why not paste, why not concrete? So why we are not
we are
going.
going on concrete, na, ma'am. We can't say we can't rule out
Huh?
concrete. Concrete cubes are there.
Yeah, that's what. So one question was why do we need to do it on mortar? Why can't we do it on concrete? I'm not telling it's wrong to do it on concrete. So what sir told is that we cannot standardize, we don't have a standard coarse aggregate. We have standard sand. So whenever we are doing it as per uh, the mortar codal provision, we are going for standard sand usage. We cannot have such a standard coarse aggregate. So that is why we follow cement mortar testing and not concrete cube testing.
So how vary does the result come, ma'am? Because if the same cement mortar is used to prepare that concrete cube,
Mm.
are the compressive strength varying, ma'am, in both of them?
I have not done in an experimental conclusion for that. So if anyone who has done that on site might be able to give a proper idea. I guess it is better to. If my personal opinion is it's better to go with concrete because if that is the realistic scenario
Yes,
on
for the
site.
final product, we are going to test the final product which is going to come onto the ground.
Yes, yes. In that case, as per the codal provision, it is better to go for concrete cubes. Is what I personally believe in. So, but it is not wrong to go for mortar also because it can also provide us idea of how the compressive strength of the mortar is going to be.
Okay.
So anyone on site, if you have any other.
Ma'am, can we mail our personal queries to Professor, ma'am? Because there are few things which I'm just starting my work as of now as part of my PhD research.
Okay,
So wanted to take his guidance and his
it's nothing wrong. You always can mail him. Also, if you have anything particular to ask him, you can put it in the discussion forum if it is particularly related to the course. If not, you can mail him. Yeah, regarding
okay,
your work, yes. Anthony sir, you are trying to. Yeah.
No, no, ma'am.
Okay.
Nothing.
So in the discussion forum, I can, sorry, in the chat box, ma'am, can we get the recorded session? Of course, it's available in YouTube. I think you are getting continuous mails regarding that in the announcement session. If not, please let me know. It is available on YouTube, definitely. Ma'am, why near the aggregates density of filling uh, paste it's less? I guess it's just again because of the wall effect. When you try to fill something is near to the surface, there will always be some voids when it comes near to the surface. We cannot fill anything fully at the boundaries. So if you consider aggregate is having some definite boundary, it's very difficult to fill the paste at the that boundary. Again, we are talking in terms of nanometers and micrometer scale, so it's not much of a difference. So that is why there is again sides when you talk about ITZ. There are researchers which tell that ITZ is not that prominent. There are researchers which tell that ITZ is still prominent. So it's both ways you can consider. To your question, it is because of the wall effect. So next one, can you suggest book for numerical on concrete technology? Can you elaborate, Shwetank? You want the uh,
Ma'am,
examples?
yes, ma'am,
Sold
for
out examples.
uh, ma'am, for numerical practice, like for competitive exams, is there any material?
For concrete technology, I personally have not followed any, but I can do some background research and get back to you. Generally, it is a theory based and application based, not a
Okay,
numerical solution based course. So yeah.
like for the mixed design and stuff like that.
Okay, that even to see the mixed designs, even in IS 456, you can see how the mixed designs vary when you add different components and all. It's a design is the procedure is almost the same. It depends upon how you vary the water content, what different percentages you add the SCMs, etc. So you can see that in the appendix. Apart from that, a book particularly for that, I'm not aware of. I can get back to you.
Okay, sure, ma'am.
Yeah. So thank you all. Let's wind up. Yeah, I yes 10262. Yes, thank you, Afia. Yeah, I was trying to get the number. IS 10262 can be used for mixed design. Yes,
Yes, ma'am. IS 10262 gives all the various different design mix of
exactly.
what would be
Not IS
slag.
456. Yes, I mixed up both. Yes, IS
Slag
one.
is there, how much slag, and if it
Yes,
is fly ash, how much fly ash. And based on that, I think there are six or seven numericals
yes.
given in that.
Appendices are there, no? Like,
Yes, ma'am.
yeah. So Shwetank, please make note of that IS number. You can get them from that.
Yes, ma'am.
Yeah, sure. So thank you. I guess that's all for today. So let me stop sharing.